Hello everybody, here to go over your Unit 3, Semester 2, Unit 3 review guide for you. Unit 3 is a much shorter lesson, only about 4 or 5 lessons total. Goes much faster, I think much easier lesson than Unit 2 was. So this hopefully will be a little bit shorter video. We are going to be covering properties of exponents. And we are going to be covering graphing exponential functions. I've seen a lot of feedback from people who have started this stuff, and they're always asking for questions on that. So we'll be discussing that throughout here. As normal, I'm going to go through and talk about each lesson for a brief second, and then also do a couple questions from the unit review guide. Make sure you're doing that unit review guide and maximizing your points on those. All 4 of those in this semester are lots of points that can really raise your grade. Okay, so first thing you're going to be looking at are the properties of exponents and simplifying rational expressions. This is 3.1, a really important lesson. This is telling you that whenever you have 5 squared and x to the third, or 5 to the fourth, n to the third, any of those types of things. Small numbers the exponent, or called the power, big numbers the base. Right under this in your lessons page, this slide deck of the product rules, okay, these are the power rules, is very important that you look through. You should go through this little green title, get the beginning, and you should write out what each of the rules look like. And they look something like a to the m times a to the n equals a to the m plus n. This is telling you that if you have the same base, a, being multiplied together, if you think about what exponents mean, it just means I have this many and I have this many, so I can just add them all up. And if you have a to the m power raised to the n power, then you multiply them, because again, if you think about what it means you have 5 sets of 3 or 3 sets of 2, and those are going to be multiplication problems. One of the other big ones is if you have a to the m over a to the n, and you think about what that means. So many a's over so many a's, you would cancel those out, and so you would get still a. You would not do the math with the base, but you would take m minus n. And this little item right here called the power rules, go through each of those, write those down. That will make your homework much easier to do. So this one has lots involved. It has a quotient, and it has a power up here. This 2 is going to get distributed. Basically, it's really not called distribute, but it's similar to distributed. Everything in parentheses is to the second power. So you have 3 squared, and you have x squared, squared, and then you have y to the 4th squared. And you're going to simplify that. 3 squared is going to give me 9. X squared squared is going to give me x to the 4th. And y to the 4th to the 2nd, 4 groups of 2 is going to give me y to the 8th. That is your final answer there. Looking through those items there, looks like we would be at this last one down here. This is problem number 2 on the review. Now, the x's and y's are not the same variable, but if this had been like x to the 4th over over x to the 1st, then I would have done this math and had x to the 3rd. So if you can simplify, you simplify as much as possible throughout there. Here we have a product, and so we're going to take all the x's that we have, 3 here and 6 there. That means we have x to the 9th. Y to the 4th, y to the 7th means we're going to have y to the 11th. X to the 9th, y to the 11th. Next one you have is simplifying square roots and monomials. We did a little bit of this simplifying square roots in the first chapter. In the first semester, there was some lessons like this, so some of this is review. It's just going to be going over with more variables involved than just numbers. So assume all variables are positive. So we learned how to do square root of 75 in first semester. You're going to break that down into perfect square of 25 and 3. And that way 25 breaks out. So I know I'm going to have a 5 out, and I'm going to have a 3 under my radical. Then I do the variable portions. And what you need to know about doing variables is that you need 2 variables to break 1 out. So I could write x to the 4th as x squared and x squared. And an x squared breaks out as 1. So I'm going to be able to break out 2 of those. In my class, when I teach this lesson, I'm always like to say it takes 2 to make 1. For every 2, 1 breaks out. If you don't have a partner, if you don't have 2, then it's left underneath. So x to the 4th means I'm going to be able to break out x squared. Y to the 3rd means I'm going to be able to break out 1y, y squared, but 1y is going to be left underneath. So this is going to be a y outside. That would represent 2, 3, and z to the 6th. For every 2 I have, so if I have z to the 6th, that means I have 3 sets. I can break out 1, so z to the 3rd. Because that would be z squared times z squared times z squared. And each of those would come out as 1. So final answer would be 5, x to the 2nd, y, z to the 3rd, 3y. If you have it under the radical, that means there's got to be an odd number there. Some of you have been typing in some answers that have had some errors in there, so check that. Simplifying expressions and dividing a polynomial by a monomial. This is the practice at the bottom there. And so if you don't know how to use these examples, what you're going to do here is maybe on your notebook paper, just try these. And then once you hit find out, it shows you what it is. So in this first one, you would have 2 to the 3rd, which is 8. And then you have 2x to the 2nd to the 3rd, which is x to the 6th, y to the 3rd. Right? Here we have some things involved with negative exponents. One of the rules in that slide deck is the power rule for a negative exponent. Anytime you have a negative exponent, you simply move that to the bottom of your fraction bar. If it's already on the bottom, you move it to the top. So in this one right here, we would have 8 divided by 4, which would give me 2. This x would move to the bottom, and this y would move to the top. So that would give me x on the bottom. And there's already an x down there, so I would have 2 x's down there like this. This y squared would move to the top, so I had y, and now I got y squared, and this z would be on the bottom. Except I can't really read my scribbles, so let me move some of that out of the way. Oh, there's a z on top and the bottom. I missed that. So those z's would cancel out. So when I simplified this out here, I would have 2 y times y squared would give me y to the 3rd, and x times x would give me x squared. When you're doing a division here, you're going to take, even though it's a long expression, you're just going to divide this into every term. Pay attention to sign. So 18x to the 4th over 3x is one term. So you would divide the numbers, 6, and then you would do the exponent rules here. X to the 4th over x would be just x to the 3rd. Then you would take 3x into negative 27x to the 3rd over x, over 3x, excuse me. So a negative divided by a positive gives me negative 9x squared. And then you would have 12x squared over 3x. So 12 divided by 3 is 4. X squared divided by x is x. Same thing here, you would be dividing that into both terms. They do not always work out nice and neat. 4 over 6 does not simplify to a whole number, but it does reduce to 2/3. 5 over 6 doesn't reduce. 3 out of 6 reduces to 1/2. So looking at a couple of these that we want to simplify, we have that negative sign. Remember that negative sign means you're going to put it as 1 over 2x to the 4th to the 2nd. A negative exponent does not mean a negative value. Notice none of your answers have a negative value. And then you're going to simplify from there. So 1, 2 squared is 4, and x to the 4th times 2, or 2 sets of x to the 4th is going to give me x to the 8th. 1 over 4x to the 8th. When you go to 13 in that assignment, you're going to take care of these numbers first. Now, 27 over 30 does not simplify nice and neat, but 27 over 30 does have factors of 3. So 3 goes into 27 9 times, and 3 goes into 30 10 times. So I'm going to have 9 over 10. Remember what I said about negative exponents? Move them around. So this x to the negative 3 is going to go down. So I'm going to have x to the 7th and x to the 3rd because it moved down. This y to the 2nd is going to come up, so it's going to be y and y to the negative 2. Oh, not negative 2 anymore. Positive 2 because I moved it. So erase that. So I'm going to simplify. 9 times y squared is going to give me 9y cubed. And 10 x to the 7, x to the third is going to give me 10 x to the 10th. 10 x to the 10th. That's what we're looking at right there. 15 is a division 1 of this sort. So we're going to be looking here at this one, and we're going to have 4 into 20, 4 x to the third into 20x to the 8th. So just do these as individual problems and see what value you get. 20 divided by 4 is 5. X to the 8th over x to the third is x to the 5th. So I'm looking for 5x to the 5th. So that means this one's gone. This one's gone. Then I'm going to have 28x to the 5th over 4x to the third, which is going to give me 7x squared, which means this one has to be the right answer, not this one. And you can confirm because 44 divided by 4 is 11, would be a negative 11x. And then, like I said, probably the most challenging lesson and things I've received the most questions about is graphing. It's an exponential function whenever you have a base that is bigger than 0 and not equal to 1. So 5x, 5 to the x, 7 to the x, 2 to the x, 300 to the x. So instead of x to a power, now the power is the variable. So when you plug in 1, you would have something to the first power. When you plug in 2, it'd be squared. When you plug in 3, it'd be cubed. So instead of changing the base, we're changing the exponent. And then this right here is the rules that you need to know about transforming items. Okay? And this is exactly what I'd be writing it down. If this number in front of the bx is a negative, then you have a reflection over the x-axis. If this number's absolute value is bigger than 1, so meaning it's not a fraction, then it's stretched vertically. If it's smaller than 1, then that means it's compressed vertically. And then you also have some things that go on when you add or subtract some items to the x value there. And you can see what those things looking like: stretching, compressing, and shifting to the right and shifting to the left, moving up and moving down. So things that you want to know about that are changes here. Anytime you add or subtract a value to the exponent, that is going to shift it right or left. Okay? So this is a right or left move. And then anytime you have like two, I guess I should say two, or let's say negatives 2 to the x power plus 5, this plus 5 is going to move it up or move it down. Okay, so if you're adding a number to the whole thing, not to the exponent, this would move it up 5. If it was minus 5, that would be down 5. Definitely take a look at the 5 or 6 examples in the lesson, and they'll help you see what we're looking for. But basically, you just need to know that if this is the straight up start function of that they've graphed for you there, and that it's just saying, hey, this exponential function always looks just like this. Anytime we graph it, just like this. So that's a little high. And then you can move all these things around, changing the way it looks by all the things you do to that. And so you're not going to have to do a ton of graphing. You do some things on the Desmos calculator and different things like that. Or maybe that's in chapter 4, sorry. You can use the Desmos to help you figure that out. But basically, you're just looking for, is this going to make it bigger? Is this going to flip it over? Is this going to stretch it? It's basically knowing about this number. Bigger than 1, it stretches it. And smaller than 1, it compresses it. And if it's a negative, it flips it over the graph. So, which of the following represents exponential decay? So one of the other things is the exponential decay and exponential growth. Those are topics that are in there. An exponential decay is when the a value is less than 1. So when I look at these options, I have the a value here, whatever's in front. 1/4 or 4. Can't be neither of them. Definitely can't be both. Less than 1 is decay, which probably means that if A is greater than 1, you have exponential growth. And again, there's some great videos in there that can help you with looking at what would that look like, exponential growth or exponential decay. Okay, so looking at a few of those. Select all of the descriptions for this equation. Okay, this is what the original was, so just 1/2 to the x power. And now we're going to do all of these changes. So I have a positive 3, which means I'm going to have a vertical stretch because that is bigger than 1. Okay, then I have x minus 2. X minus 2 is going to shift that 2 units to the, let me double check my notes because I don't want to tell you wrong. Oh, I'm on the wrong page. X minus 2 is going to shift it 2 units right. And then we have this minus 1. And remember what I said, whenever that happens, that means it's going to move up or down. And if it's positive, it would go up. If it's negative, it's going to go down. So it's going to be a vertical shift down 1. And so basically, it's just understanding what each of these 4 parts tell us has changed this original item. That wraps it up for me on Unit 3. Only got one more unit to go. I'll be posting Unit 4's video early next week. Thanks for watching.